Superposition in quantum theory. Have you ever stood in front of your fridge, caught between choosing toast or cereal for breakfast? You're not just being indecisive. You're living in a state of quantum superposition. Well, metaphorically anyway. In the normal world, you're either reaching for the jam or the milk. But in the strange and wonderful quantum realm, you're in a delicious, buttery superposition of both possibilities until you open that fridge door. Then, bam, the wave function collapses and a choice is made. Superposition isn't magic, it's just potential held in suspension. It's like waiting for a text back from someone you like. You're in a superposition of getting a yes and a maybe later. The math behind it isn't as scary as it sounds, it's just keeping score. It tells us the probability of each outcome. When scientists talk about a state being 1 over the square root of 2 times 0 plus 1 over the square root of 2 times 1, they're not getting philosophical. They're literally describing a perfect 50/50th chance. But here's where it gets really cool. That number, that 1 over root 2, isn't just a simple value. It's a complex amplitude, which means it carries a hidden property called phase. Think of it like a tiny, invisible dial. By twisting this dial, we can create something called interference. This is the secret behind a quantum computer's power. They don't just brute force every possible answer. Instead, they cleverly use interference to make the wrong answers cancel each other out, like a pair of noise-canceling headphones for bad ideas. So, superposition plus interference equals the quantum advantage. It's not about being faster at adding numbers. It's about letting probability waves talk to each other to find the right solution. This isn't just theory. Even a single particle of light, a photon, can be in a superposition. In a famous experiment called the Moxender interferometer, a single photon is sent toward a beam splitter. You'd think it has to choose one path or the other, right? Wrong. The photon takes both paths simultaneously. It's like a ghost splitting in two, traveling along separate routes, and then interfering with itself at the end. No tricks, just the wave function doing its thing. It gets even stranger with the delayed choice experiment, where you can decide whether to observe the photon as a particle or a wave asterisk. After asterisk, it has already passed the point of choosing its path. It's as if the universe holds its breath, waiting for you to ask before it decides on the story. This brings us to qubits, the building blocks of quantum computers. A classical bit is like a light switch. It's either on or off, a 0 or a 1. A qubit, however, is like a dimmer switch combined with a disco ball. It can be 0-1, or both, at the same time, with a specific brightness in phase. This fragile state is called coherence, and it's incredibly sensitive. A stray bit of heat, a tiny vibration poof, the superposition is gone. This is why quantum labs look like sci-fi bunkers. They are super-cooled, vacuum-sealed, and shielded from the outside world to protect this delicate quantum state. Superposition is also the secret ingredient for quantum teleportation. No, not like in Star Trek, but teleporting information. You can take an unknown quantum state, entangle it with another particle, make a measurement, and the original state's information reappears instantly on the other particle, no matter how far away it is. The catch: the original state is destroyed in the process. The no-cloning theorem ensures you can't just copy and paste quantum information. It's like mailing a letter by burning it here, only to have it perfectly reconstructed there. So, superposition isn't just about being in two places at once. It's about being in a relationship with all possibilities. It's the difference between saying, "I'll decide later," and truly holding a space where all outcomes are equally valid until a measurement is made. And in a way, that feels incredibly human. We all hold hope and fear, excitement and dread, all at the same time, until life forces us to make a choice. Maybe quantum mechanics didn't invent superposition. Maybe it just gave a name to something we've been doing all along. Thanks for watching. If you enjoyed unraveling the mysteries of the quantum world with us, don't forget to like, subscribe, and hit that notification bell for more mind-bending science.